Let's solve this rational equation. So I would like to make the denominators all be the same, because when they are, I can cancel those denominators out. Let's start by factoring so we can see exactly what we have and what we do not have. So looking at this denominator right here, v squared, so that's v times v. 4, that'll be 2 times 2. Inner plus outer equals middle. Inner, I have 2v. Outer, I have another 2v. To get a positive 4, both of these need to be positive, which means these are positive. And a positive times a positive is a positive for the positive 4. So we factored it. We're good. This is identical to this, so it must be v plus 2 again. Meanwhile, over here, I've got a single v plus 2. But what it is lacking is a second v plus 2 like everybody else has. So I'm going to put another factor of v plus 2 in the denominator, which I can do as long as I do the same thing to the numerator. Now all the denominators match. Before I cancel out these denominators, let's stop and remember the excluded value. V cannot equal negative 2. I'm getting that because if I set v plus 2 equal to 0, I get negative 2. So whatever solutions we get, let's make sure that none of them are negative 2. Now the denominators are all the same, so I can cancel the denominators out. So that means I have 6 equals 1 plus some stuff. I'm going to go ahead and double distribute this like you do. So v times v, that's v squared. V times 2, that's 2v. 6 times v, that's 6v. And 6 times 2 is 12. Like terms, I've got v squared plus 8v, putting these together. And then I have 12 and I have 1, so that'll be 13. Now I'm going to subtract that 6 from both sides, get 0 over here. So that's v squared plus 8v plus 7. Probably this is factorable, so let's go for it. V squared will be v times v. 7 will be 1 times 7. Inner plus outer equals middle. Inner, I have 1v. Outer, I have 7v. To make 8v, both of these need to be positive, which means that both of these would be positive. And a positive times a positive is a positive for the positive 7. So this is working out great. Now I will set these two factors equal to 0 to get my solutions. So I have v equals negative 1 and v equals negative 7. Whoops, negative 7, man. Now let's just make sure that neither of these are excluded. Extraneous. V cannot equal negative 2. Neither of these are negative 2, so we're good. That's the solution. I'm going to keep going. Let's do another example. Alright, same strategy. We want the denominators to be the same. So I'm going to start by factoring. So I have, if I pull up the GCF, that's 3 times b minus 3. And here I have b plus 2 over 3 minus 1 over 3. real quick, b cannot equal 3. Alright, because of the b minus 3, setting that equal to 0 and solving. So watch out. Make sure that none of the solutions we get are 3. All of the denominators have a 3 in it, so that's great. But this denominator has b minus 3, so I'm going to need a b minus 3 here. I can add that extra b minus 3 in only if I do the same thing in the numerator. And I'll do the same thing here. B minus 3 and another b minus 3. Now the denominators are all the same. So I can cancel those denominators out now. Goodbye. One thing, you have to be real careful about how you deal with a subtraction sign. It's probably safer if you take this minus sign and stick it up here on the 1. So I'm going to make this a plus and put that minus sign way up here. That way when I do the distributive property in a minute, I'll remember to distribute a negative 1, not a positive 1. So this negative 3 is going to turn into a positive 3. That's the big mistake that students make, but not you. Not you. You're too smart for that. So I'm going to bring down this 5. I'm going to go ahead and double distribute right here like you do. So b times b, so that's b squared. B times negative 3, that's negative 3b. 2 times b is 2b. 2 times negative 3 is negative 6. And like I said, distributing this negative 1. So negative 1 times b, that's negative b. And then negative 1 times negative 3 is positive 3. That's the big mistake people will make. I will often see a negative 3 right here. So combining like terms, okay, I've got my b squared. So look at all these b terms. I've got negative 3b, and I've got 2b, and I've got negative 1b. So let's see. Negative 3 and 2, that's negative 1. Negative 1 and another negative 1, that's negative 2. Okay, so that's what I have. So I have negative 2b. And then I have negative 6 and positive 3, so that'll be negative 3. Then I'm just going to subtract this 5 from both sides. So I'll have 0 is equal to b squared minus 2b minus 8. Probably this will be factorable. Let's give that a try. B squared will be b times b. 8, probably going to go with 2 times 4 as opposed to 1 times 8. Inner plus outer must equal middle. Inner, I have 2b. Outer, I have 4b. To get a middle of negative 2, I need a positive 2 and a negative 4. That means positive here and negative here. A positive times a negative is a negative for the negative 8. So this is working out just fine. To get the solutions, I just need to set these two factors equal to 0. So here I'm going to get b equals negative 2 and b equals 4. Okay, let's check the excluded values. B cannot equal 3. That is a fact. But none of these are 3, so we're good. So these are the two solutions, negative 2 or 4. Okay, so that was number 2. Let's keep going. I think I'll keep going until we get to number 5. Then I'll make a new video at that point. Alright, same deal. I want all the denominators to be the same so I can then cancel them out. It's a little bit weird. I'm noticing that these denominators are already the same. So, normally I would factor these down, but I don't think that's going to be necessary this time, because all I really need is for this first one to have the same denominator as the others. So all I have to do is give this first, this number 1 a denominator. See, I need a little more space. I need to make this into a denominator of x squared minus 11x plus 24. And I can do that as long as I put the same thing in the numerator. Alright, x squared minus 11x plus 24. Now this makes sense. Anything divided by itself is 1. So I'm just replacing 1 with this trinomial over itself. So it makes sense that this should be 1. But at that moment, even without factoring, I have all the denominators the same. So I really didn't, it would have been a waste of time to factor. Except for one thing. I kind of will have to factor to see what the excluded values are. But we'll do that at the end. For now, I'm going to follow through and cancel these out. Cancel all that out. So what I have now is just the numerators. So at this moment, I have x squared minus 11x plus 24. All right, that's that. And then now here comes the minus 1 right here equals x plus 3. All right, that's all of it, except for my square disappeared for some reason. So like terms, so I have x squared minus 11x plus 23 is equal to x plus 3. I just did 24 minus 1. I'm going to get 0 over here by subtracting x from both sides and subtracting 3 from both sides. So now I have x squared minus 12x plus 20 is equal to 0. Probably this is going to factor. So let's do that. X squared is x times x. 20, when I look at 20, it's either going to be 4 times 5 or 2 times 10 or 1 times 20. I'm trying to get 12 in the middle, so I'm going to use the 2 and the 10 because I know I can get 12 out of that. So 2 times 10. Now, inner plus outer must equal middle. Inner, I have 2x. Outer, I have 10x. I'm trying to get negative 12. So both of these would have to be negative to make negative 12. So that means both of these would have to be negative. A negative times negative is a positive for the positive 20. So this is working. Alright, setting these factors equal to 0 will get me my solutions. So I have x equals 2 or x equals 10. So now I just need to double check and make sure that none of these are excluded. So I am going to go back. My only denominator was this x squared minus 11x plus 24. So I am going to go back and just factor that guy, and so I can get my excluded values. X squared is x times x. 24 is 3 times 8, among other things. Inner plus outer equals middle. So inner, I have 3x. Outer, I have 8x. To get negative 11, both of these would have to be negative. So negative here and negative here. And a negative times a negative is a positive for my positive 24. So this is how you would factor this, which tells me that x cannot equal 3, x cannot equal 8. Those are my excluded values. So neither of these are excluded, so those are my solutions, 2 and 10. Okay, let's do 2 more problems on this video. Interesting. So we have some factoring to do. So I have 1 over So I'm seeing a common factor, so I'll bring out the GCF of b. That'll leave b minus 1. Okay. And then same thing here. B squared minus b, that's that GCF of b, and then b minus 1. There's no need to factor this up here. There's no need for that, except for if something cancels. But even if it did, it would have to match this anyway, so I'm not going to bother. So b squared plus 5b plus 4. So let's make all the denominators the same. This denominator has a b and a b minus 1. So to make these the same, this denominator will need a b, which is fine as long as I put one in the top as well. And that's it. All of the denominators are now the same. Let's mention the excluded values before I start canceling everything out. B cannot equal 0 because of the b, and b cannot equal positive 1 because of the b minus 1. Alright, now we can cancel out these like denominators and make a new equation out of the numerators. So it's 1 plus b is equal to b squared plus 5b plus 4. Let's get 0 over here. So subtract 1 from both sides and subtract b. So 0 is equal to b squared plus 4b plus 3. Alright, let's try to factor this. B squared is b times b. 3 is 3 times 1. Inner plus outer must equal middle. Inner, I have 3b. Outer, I have 1b. To make positive 4, both of these would need to be positive, so both of these would be positive. Positive times a positive is a positive for the positive 3, so this is working. Alright, let's set each of these equal to 0. So that gives me b equals negative 3, or b equals negative 1. Let's make sure none of these are excluded. B cannot equal 0 or positive 1. Here we have negative 1 and negative 3. So neither of these are excluded, so we are good. These are the solutions. Okay, let's put one more problem on this video, and that'll be problem number 5. The good news is there's nothing that we need to factor. So to make these denominators the same, all I really need to do is give this denominator a factor of 5k minus 7, like the others. I can only do that if I also put a factor of 5k minus 7 in the numerator as well. Now the denominators are all the same, so I can cancel them out. Before I do, let's mention the excluded values. K cannot equal 7 over 5. Alright, I'm getting that by setting this equal to 0. Add 7, divide by 5, that's 7 over 5. Okay. Anyway, the denominators can be canceled out now, and we can make a new equation out of the numerators. So I have 5k plus 5 is equal to 6k squared minus 10k minus 4 minus. Now I have to be really careful about this because I have this minus sign. So what I need to do is I need to double distribute this. I need to multiply these two binomials. But whatever I get for the answer, I'm going to have to distribute this negative sign. So I'm going to multiply this out, but I'm going to keep it in parentheses so that I can be sure to distribute the negative sign later. Alright, so that's what I'm going to do. So here I go. Boom, boom. So 3k times 5k, that is 15k squared. 3k times negative 7, so that's negative 21k. Alright, and then here we go. So 6 times 5 is 30. So that's 30k. And 6 times negative 7 is negative 42. Okay, so when I bring this down, I've got 5k plus 5 is equal to 6k squared minus 10k minus 4. But now I'm going to distribute this negative sign throughout. You know, I guess technically I should combine these like terms right now. This is getting tedious. So I'm just going to combine like terms first. So still in here, I've got 15k squared, negative 21k, positive 30k. So that is positive 9k minus 42. Now, just recopying all this mess again. It's annoying. So now I'm just distributing this minus sign, my people. So this will be negative 15k squared minus 9k plus 42. Alright, dealing with that negative sign properly, that's crucial. That's the mistake that most people make, is not distributing that negative sign. So just be really, really careful to put all this in parentheses and then distribute the way I just did. Anyway, so now I can combine like terms and such. Let's see. So I've got 6k squared minus 15k squared. So that's what? Negative 9k squared. Okay, now how about these k's? I've got negative 10k, negative 9k, that's negative 19k. And I've got negative 4 and positive 42. So that's positive 38. Okay, now we're getting somewhere. So let's subtract 5k from both sides. And let's subtract 5 from both sides. So now I have 0 is equal to negative 9k squared minus 24k plus 33. Alright, I'm not liking the fact that the leading coefficient is negative. It makes factoring more difficult. So I am just going to divide everything by negative 1 to change all the signs around. So of course this will still be 0, but I will have positive 9k squared positive 24k minus 33. Is anybody else noticing there's a GCF here? Yeah. All of these are divisible by 3. So before I try to factor this as a binomial times a binomial, I'm going to bring out that GCF of 3. So that'll leave 3k squared plus 8k minus 11. Okay, now I'll factor it the rest of the way. So this is kind of a long problem. 3k squared can only factor as 3k times k. Now 11 can only be 11 and 1. And I'm going to put it like this. I know if I put the 11 over here, that would make 33, so that can't be it. Inner plus outer must equal middle. Inner, I have 11k. Outer, I have 3k. To make positive 8, I need a positive 11 and a negative 3. So that's positive here, negative here. Positive times negative is a negative for the negative 11. So this is working out great. Okay, to get my solutions, I'm just going to set these factors equal to 0. So I'm going to set 3k plus 11 equal to 0, and I'm going to set k minus 1 equal to 0. Okay, so this will be 3k equals negative 11, and k is equal to negative 11 over 3. And of course, from this, I get k equals 1. Alright, notice I didn't do anything with the 3. You can't set 3 equal to 0. Alright, it's a constant, and it does not equal 0. So I just ignored it. So these will be my two solutions. Let's just look back and make sure none of them are extraneous. K cannot equal 7 over 5, but these are both okay. So those will be my solutions here. Okay, and that was the 5th problem. So this is a good point to stop this video.